Let's get started with an introduction to virtualization. First of all, what is virtualization? Virtualization is the process of creating a software-based or virtual representation of something such as virtual applications, servers, storage, and networks. Virtualization as a concept isn't something that is brand new. It actually began in the 1960s as a method of logically dividing the system resources provided by mainframe computers between different applications. There are multiple types of virtualization, and we will cover most of them in the next module, but for now, let's take a trip back into the not-so-distant past. Before virtualization, if we take a look maybe 10, 20 years back, in each company's data centers, we had a ton of servers, and each server had a different purpose, maybe running on different hardware and even with different operating systems. Each new application that you installed, the vendor required that their application ran on a dedicated server. Each one of those servers had their own CPU, RAM, and hard drive resources, of course, and each one of them needed enough resources for the utilization at their peak time, as this is what we needed to calculate for each server. How many resources will it need at peak time? But what this did is that on average, most servers were really underutilized, and organizations were spending a ton of money on hardware that most of the time was not even used at 10% of its capability. If we take a look at the four main problems of the data center before virtualization, we of course have the low utilization of resources that we just talked about. Another problem is the space needed to host all of those servers. With one server per application, high availability and disaster recovery requirements, the number of servers needed was really growing exponentially, and there's always a cost needed to even having a bigger data center to accommodate all of those servers, as well as talking about initial hardware cost and maintenance cost. A traditional non-virtualized model is also not flexible and often introduced delays in projects. As part of every software implementation, we always had to plan for buying new hardware, needed to wait for the manufacturer to deliver it, IT to install it, and was always a big extra cost as part of every project. Finally, with the greater amount of servers, a lot of hardware maintenance is needed in order to keep everything running, so those are extra man hours which again add up to the cost. So how can virtualization help? Let's dig deeper a bit into what virtualization actually is. With virtualization, we still have the physical server as we did before, but we have this new virtualization layer here called a hypervisor that has all of the drivers and requirements to control the underlying hardware. Above this virtualization layer, we then have our virtual machines, which were our dedicated servers before, but now they can be on that same physical server. They can have all different numbers of cores, RAM, storage attached to them, and they can even be of different operating systems. The virtualization layer will present to those operating systems generic drivers and hardware depending on the vendor that you use for your hypervisor. So if you use, for example, VMware as your hypervisor, the operating systems on top will see a generic VMware storage drivers, generic VMware graphic drivers, and so on. With virtualization, we are no longer limited to only one operating system per server. We can really have a Windows, a Linux, virtual machines, all running on the same physical server. Also with virtualization, those virtual machines are encapsulated and isolated, so one virtual machine cannot impact the other if one of them gets a virus or goes corrupt. Because it lives in its own bubble, it really cannot damage the underlying hardware or take more CPU or RAM than what you have assigned it in your hypervisor tool. So if we recap the terms, the physical server is also called the virtual host. We also have the virtualization layer, as we have specified before, which is called the hypervisor, and over that we have our virtual machines. So what are some advantages of virtualization? We talked a bit about them before, but let's do a quick recap. First of all, it allows the operating system of a physical server, like Windows Server before, to run on a virtual layer. And this also allows you to run multiple virtual machines on the same hardware, so we can really maximize the utilization of our hardware, even if we have one virtual machine per application. Also, each virtual machine has their own operating system, CPU, storage, and I/O resources, so really each one of them can use the resources it needs, but never more. Virtual machines are also portable. As long as you use the same hypervisor, you can actually move a virtual machine from one virtual host to another without having any driver or compatibility problems, because the virtual machines really only know the hypervisor as their host. This allows you to, like, say in your data center, you have a Dell server and an HP server. You need to do some maintenance, maybe on the hardware or even on the firmware of the Dell server. You could move all of those virtual machines to the HP server. Again, it doesn't really care about the physical server in the back. As long as the hypervisor is the same, then you can do your maintenance and move the virtual machines back without impacting the end user. This really gives you that flexibility and allows you to have a better availability and resiliency for your services. While in this course, we will not deep dive into any specific vendors, the big players in the virtualization space are VMware with vSphere, Microsoft with Hyper-V, Citrix with Citrix Hypervisor, Oracle with the Oracle VM Server, and Red Hat.